This first section of chapter 7 is on exponents. So we have some values that you are supposed to know. So let's fill in this table. 2 squared would be 4. 2 cubed would be 8. 2 to the 4th would be 16, and 2 to the 5th would be 32. 3 squared would be 9. 3 cubed would be 27. 3 to the 4th would be 81. 3 to the 5th would be 243. 4 squared, 16. 4 cubed, 64. 4 to the 4th, 256. And you won't have to know 4 to the 5th. X squared, 25. X cubed, 125. X to the 4th, 625. You will not know 5 to the 5th. 6 squared is 36. 6 cubed is 216. And the rest of those you don't need to know. 7 squared, 49. 7 cubed, 343. 8 squared, 64. 8 cubed, 516. 9 squared, 81. 9 cubed, 729. 10 squared, 100. 10 cubed, 1,000. 10 to the 4th, 10,000. 10 to the 5th, 100,000. Every power of 10 you should know because you just put that many zeros on there. 10 to the 1 had 1 0, 10 squared had 2 zeros, 10 cubed had 3 zeros. So I should be able to ask you any power of 10. 11 squared will be 121, and that is all you need to know. 12 squared, 144. 13 squared, 169. 14 squared, 196. 15 squared, 225. And I'm just going to add 25 squared, 625. So these are all values that you should know by heart. Okay, let's do a little investigating. When we have a number written in its radical form, so I'm going to write it like this, we call this the root index. And this would be the base. And then this would be the exponent or the power. So we will always rewrite it from radical form to exponential form as the base to the exponent divided by the root index. Or some people say the base to the power over the root. So let's just rewrite these. The 4th root of 16 cubed would be 16. The power is 3 over the root is 4. And since they are written as one exponent, we must raise it and it must be written smaller. It cannot look like 16 to the 3/4 because that is 16 and 3/4. So I'm going to be very particular about how I see them written. Make sure when you're writing them as an exponent, you raise it up and make it smaller. So this base is 81. My power is 3. My root, when there isn't one, is a square root, so that's 2. 81 to the 3 halves. This is a -8 as my base, and it is raised to the power of 5 over the root of 3. -8 to the 5/3 power. Base is 81, power is 3, root is 4, 81 to the 3/4. Now let's go back from the exponent form to the radical form. So I'm going to put my root index. My base is 8. My power is first, so that's my 4. My root is 3, so I write a little 3 up here in the index. Again, I'm going to be particular about how they look. The 3 should be little and written above there. So this next one, my base is 36, power over root, power is 3, root is 2. In this one, my base is 4, my power is 5, my root is 2. And in this last one, my base is a -32, my power is 2, and my root is 5. Now, whenever we evaluate a polynomial, or excuse me, a radical, it must be in radical form. So to evaluate, it must be in radical form. So we will always do the radical first because that will give me a smaller number, and then do the power. So the 4th root of 16 will be 2, and then I still have this cube to do. So it is 2 cubed, which is 8, and that's the work I want to see. So in this next one, the radical square root of 81 is 9, and I still have to cube it, which would give me 729. Do the radical first. The cube root of a -8 is a -2. Put all your negatives in parentheses, raised to the 5th power. That is a -32. The 4th root of 81 is 3, cubed is 27. Excuse me. The cube root of 8 is 2 to the 4th is 16. The square root of 36 is 6 cubed is 216. The square root of 4 is 2 to the 5th is 32. The 5th root of a -32 is a -2 squared is a +4. So I'm going to be particular about where those negatives are, and if you write this one as you think that reads -2 squared, it actually reads the opposite of 2 squared, and this answer would be a -4. That is wrong. It is the 5th root of a -32, which is -2. I want that put in parentheses. Then you are raising it to the 2nd power. So that is a -2 times a -2 is my +4. Here's just a recap of that. Root of the base to the power equals base to the power over root. I also want you to pay attention to the fact that when the root index is even, the base has to be positive to have a real number solution. If it is not positive, we would get an imaginary solution. And we want all of our roots to give us real solutions. If the root index is odd, the base can either be positive or negative, and we will have a real number as our solution. So knowing that, it says find the real root of a. So in other words, n is my root index. So for this first problem, this is the fifth root of a negative 32. Can you take a fifth root of a negative number? And that would be yes, and I should get a negative 2. Part B, the fourth root of 16. That would be 2. C, the fourth root of a negative 16. That is not possible. Actually, I should say that is not real. Write each radical form and evaluate. So we're going to rewrite these. So my base is 16, my power is 5, my root is 2. So if we're going to evaluate it, we do it in this radical form. The square root of 16 is 4, 4 to the fifth. That was not one on our chart, so I'm going to put that in my calculator. 4 to the fifth is 1,024. My base is 64, my power is negative 2, my root index is 3. So I do my root first. The cube root of 64 is 4 to the negative 2. That means 1 over 4 squared. That means 1 over 64. Now this says write it as an exponent form and then evaluate. So exponentially, my base is 49, my power is 3 over my root is 2. But to evaluate, I do this radical form. 7 cubed should be 343. Base is 16, power is negative 3, root is 4. To evaluate, I do the radical. The fourth root of 16 is 2 to the negative 3. That means 1 over 2 cubed. That is 1 over 8. And finally, we're going to use that in solving. So if I'm solving for x, I want to keep the x to the fourth alone. So I would divide by 6, and I get x to the fourth equals 625. So to undo a fourth power, I would fourth root it. So x will equal, and when I take the fourth root of something, just like when I took the square root of 25 and I put that square root on, I got a plus or minus 5. Any even root, I'm going to have to take as a plus or minus. Odd roots will be exactly what they are. But if you put an even root index on a problem to solve it, then you get plus or minus. So this is x equals plus or minus 25. X plus 1 cubed equals negative 64. So I'm going to cube both sides. So this is x plus 1 equals, the cube root of a negative will be negative. The cube root of 64 is 4. Subtract 1, and I get x equals negative 5.